Hello students, in this lecture we will be talking about the physical nature of matter. In the first lecture, until this topic, we have already discussed that matter is everything you see around you is made up of matter. Now we have to see what is matter made up of, correct? We already know that substances are made up of matter. We also have to see that what is matter made up of, correct? So matter is made up of particles, tiny particles. In this lecture, we will basically be proving this particular fact only, that matter is made up of very tiny particles. How can you, the easiest example that you can observe is breaking of glass sheet. So someday you would have seen whenever a glass substance breaks, it breaks down into a lot of smaller particles of glass. There are very tiny particles also, bigger pieces also, but you can see that glass breaks into a lot of tiny particles, which means that glass was made up of those particles only, correct? After breaking it gave the particles. So it was made up of the same particles only, which means that glass was made up of very tiny particles. This is the easiest example that you see around yourself. So basically anything that you see, your table, your book, your chair, is made up of matter, which ultimately is made up of very tiny particles of the same substance. Correct. Now to prove that matter is made up of very tiny particles, we have certain experiments which show us that all the matter is made up of tiny particles. Correct. The existence of particles can be shown by experiments on dissolving or mixing different substances in water. For example, you dissolve sugar or salt in water. Brownian motion also proves that matter is made up of tiny particles which are motion. What is Brownian motion? Brownian motion is the zigzag movement of particles inside the liquid. You have a particle, you have a solution, for example. This is the solution. Correct. In this solution, you have water. In this beaker, you added some salt in the water. So the salt will mix into the water and the particles will be at random positions inside the water. Now each particle will have different kind of motion in any directions due to different collisions with other particles. Due to the collisions with other particles, the particular particle that we are talking about will have a zigzag motion which is known as Brownian motion. Correct. So on dissolving, let us take a simple experiment. For example, you have to prepare a simple solution of copper sulfate. You have a beaker in which you put some copper sulfate crystals. These are basically blue in color. Correct. Now you add some water to it. Copper sulfate is this compound. We also call it blue vitriol. Okay. So in this beaker in which we already have copper sulfate, you add water. Okay. What happens is after you add water, it becomes, let us discuss this in detail. You have the solution again, and now this solution will turn blue. This whole solution will turn blue. What does this prove to you? What can you observe after you see that the solution has turned blue completely? This is because the copper sulfate that was present on the base of the beaker is a form of matter and it breaks into tiny particles which travel throughout the solution and give a color to the whole solution, which is blue, which means that the particles which were accumulated in this substance here, these particles break down into very tiny particles and spread throughout the solution to make the whole solution look blue. Correct? This is how we say that the matter is made up of tiny particles, and these particles when present in a solution are in continuous motion, which is known as Brownian motion. Correct, students? The copper sulfate crystals are made up of millions of tiny particles. On dissolving, the crystal breaks into tiny particles and the particles spread throughout the solution, which impart a blue color on the solution. Correct? Now students, on dissolving copper sulfate in water, the water is colorless. We already know water is colorless. On adding copper sulfate, the solution turns blue. Correct? This is because we have already discussed why this happened. Similarly, we can do this with potassium permanganate particles as well, but we have a different kind of experiment for that compound. The blue colored compound spreads throughout the solution to make it look blue. Similarly, when we add common salt in water, you have a solution, you have a beaker in which you have water, you have added salt to it. We have already discussed, I gave that example, but let us see this again. You have added salt. Now if you taste the solution, you will notice that the solution is salty. The whole water tastes salty. This is because the salt has broken into tiny particles, and these particles have spread throughout the solution, which give it a salty taste. Correct? So students, the next property that we will be discussing is the particles of matter are very small. We already now know that matter is made up of particles. How can we say that these particles are very tiny? We will be discussing it with the help of this example. Extremely small and cannot be seen even with a powerful microscope. They are so tiny that they cannot even be seen with the help of powerful microscopes. We have seen that on dissolving copper sulfate and common salt in the water, they break into tiny particles. This we already know, right? Let us perform the activity to read this in detail. What is the activity? You will take 6 test tubes. You can see 6 beakers in front of you. You can also take 6 test tubes. What do you do? Place the test tubes in the test tube stand. Label them 1, 2, 3, 4, 5 and 6. Correct? You have labeled them. In the test tube number 1, drop one small crystal of potassium permanganate. Firstly, you had only water. This is the result. Firstly you have clear solutions. 1, 2, 3, 4, 5 and 6. What happens is you have this solution, you have this beaker in which you have water. You have put one crystal of potassium permanganate inside the solution, inside the water. So this beaker gives this color. It was earlier colorless, but now it has become dark purple because you put a potassium permanganate crystal which is KMnO4, which is purple in color. Okay, so due to the presence of potassium permanganate, the solution has turned purple. Now what do you do next? You take out the test tube from the test tube rack. By placing your thumb on its mouth, you shake it, you have the color dark purple. Okay, with the help of a dropper, take 2 to 3 drops of the solution number 1 and place these drops into the beaker number 2, which has only water. All of these have only water left. Only this first beaker has the crystal of potassium permanganate. So you put 2 to 3 drops of this solution, 2 to 3 drops of the solution number 1 into beaker number 2. Correct? This is where you put the 2 to 3 drops. From this solution, you are putting 2 to 3 drops here. What happens is it also gives a dark purple color, but it is lighter than this one. This is more darker. The first one is darker and the second one is not that dark. It is lighter than the first one. Correct? Now you repeat the same procedure. You take the solution and you put 2 to 3 drops of this solution into beaker number 3. This gives even lighter color. You repeat this procedure, keep on repeating, and ultimately you obtain a very light purple solution which is nearly colorless. What does this tell you? That one particle of potassium permanganate, one crystal of potassium permanganate can give color to so many solutions, to such a volume of water. Why? How is it so? We only dissolve the crystal in the first beaker. How can the color spread to all the solutions? This is because that the crystal is made up of particles which are very tiny. So when you took 2 to 3 drops, or you filled the half dropper and you put the solution into the second beaker which was only water, You put a lot of particles, you put millions of particles into the second solution, which again spread into the solution and made a purple solution. And in turn, you kept on doing this and you spreaded the particles in all the beakers, which means that the particles are very small and matter has millions of particles. That small crystal, 2 to 3 crystals will have more than hundreds of millions of particles because the particles are very tiny, correct? You will notice that the color of the solution is deep pink in the test tube number 1, or you can say deep purple. Pour one drop, when you pour the 2 to 3 drops of solution number 1 into solution number 2, the color lightened, correct? However, the color of the solution becomes less and less pink or purple in the test tube number 2 to test tube number 5. Till then, the test tube number 6, the pink color is hardly visible, the purple is hardly visible, correct? It is nearly colorless. Why does this happen? Because the number of particles are decreasing at every level, right? You had all the particles in the solution number 1, you had less number of particles in the 2, even less in 3rd, even less in 4th, even less in 5, and the least in 6th. You have very less number of particles in the solution number 6 because you have kept on diluting the solution, correct? It is because the particles of potassium permanganate decrease gradually from test tube number 1 to test tube number 6. From the above observations, it can be concluded that the particles of matter are very small. They are so small that they are not visible to unaided eyes, correct? So the conclusion can be easily drawn. In the above activity, we have seen that the purple color will not disappear altogether, though it becomes lighter with each dilution. It becomes lighter. It has not disappeared though, right? You can see that this is still a solution which is pink colored, but it is very light, correct? Thus, we can say that there must be millions of tiny particles present in a small crystal of potassium permanganate, correct? That keeps on dividing into smaller and smaller number with each dilution, therefore making the color of the solution lighter and lighter. Thus, we can conclude that the matter is made up of extremely tiny particles that cannot be seen even with the help of a powerful microscope, correct? So, what did we learn in this lecture? We learned that the matter is made up of very tiny particles, and these particles are very small. This is what we learned. In the next lecture, we will be discussing about the characteristics of particles of matter. Thank you for your attention.